Dear students, I am Dr. Rajiv Sapre and this is 67th audio for you. In this audio, I will continue with the limits that we are discussing. So we have already discussed limits of algebraic functions, limits of trigonometric functions, limits of trigonometric functions by substitution, right? All these three different things we have already discussed, and now we are going to discuss today about limits of exponential functions and logarithmic functions. Now whenever you are dealing with exponential functions, it means we are going to work on limits of the functions involving e raised to x or a raised to x. It will involve a raised to x, e raised to x. These two are called exponential functions, right? And logarithmic functions also. Whenever log is involved, log of something is involved in the problem that is given to you, of which you are expected to calculate limit, then it is called as a limits of logarithmic functions. Now, as I told, here also you have to remember certain formulae. The first formula is limit x tending to 0, a raised to x minus 1 upon x. Limit x tending to 0, a raised to x minus 1 upon x. Limit x tending to 0, it is log of a. Here we are assuming that a is positive, a is greater than 0, a is a real number greater than 0, and a is not equal to 1. Okay, these are the things that we are assuming. It is needed because you can see easily that log of a, whenever I am taking, a must be positive real number, because the domain of log function is positive real numbers. This is very important. Okay, so this is to be taken care. Whenever I am using a raised to x minus 1 upon x, limit x tending to 0 is log of a. These things are there. And another property or another formula for the limit, that is replacing a by e. So it becomes limit x tending to 0, e raised to x minus 1 upon x. And it is log of e to the base e. But you know that log of e to the base e is 1. So these are the two formulae. Another two formulae are, if you take limit x tending to 0, 1 plus x bracket raised to 1 upon x, 1 plus x bracket raised to 1 upon x, then limit of this quantity as x tends to 0 is e, where e is an irrational number. Okay, e is a number which lies, value of e is lying between 2 and 3. It is a number which is 2 less than e less than 3. Approximately it is 2.73. And remember, it is an irrational number. Pi and e are the two numbers that you will come across in your study of mathematics in 11th and 12th standard. And you have to note that this e will be irrational number, pi is also irrational number. So this is one formula, limit x tending to 0, 1 plus x inside the bracket raised to 1 upon x is e. And another formula is limit x tending to 0, log of 1 plus x upon x. Log of 1 plus x, total thing upon x. It is not 1 plus x upon x. It is log 1 plus x in the numerator upon x, limit x tending to 0 is 1. Right? So these four formulae will govern any problem on exponential limits. And as I am always telling you that every problem in limit that you are trying to do, it will be a problem where your abilities of converting that problem without changing the value of the given material, so that you can use the formula. So you have to bring the situation in the problem where you can use the formula That is all about limits, and it requires a lot of practice. You should solve in these 2 years, because in 12th standard you will be studying continuity, or in future not necessarily 12th standard and all that, you will in future study about continuity, you will in future study about derivatives. All these things are depending on the concept of limits, and that is why the your strong knowledge of limits, your ability to solve the problems on limit will be very important, and it will help you to understand further concepts. So these are the 4 formulae. Again I will repeat: limit extending to 0, a raised to x minus 1 upon x, it is log of a to the base e. Second formula, limit extending to 0, e raised to x minus 1 upon x, the answer is 1. Third formula, limit extending to 0, 1 plus x bracket raised to 1 upon x, this is e. And fourth formula, log of 1 plus x upon x, limit extending to 0 is 1. Right? And in all this you have to remember certain things. E is an irrational number. I told its approximate value is 2.72, 73, etc. Then E is taken as the base of logarithm. Logarithm to base e is called natural logarithm. Napier's logarithm it is called. In some books you will find ln there. Ln is log to the base e. Okay. And when the base of logarithm is taken as 10, right, then it is called common logarithm. Common logarithm and natural logarithm. Values will be different. Common logarithm means base 10 and natural logarithm means base e. If the base of the logarithm is e, it is customary not to write the base e. Thus log x means log of x to the base e. It's not written. If the base is other than e, then you have to mention it. For example, suppose I have to take log of x to the base 10, I should write it log x base 10, log x base 8, log x base 5, etc. Okay. So this is what we have to remember. And then I have just told you about the formula log of 1 plus x upon x, limit extending to 0 is 1. Instead, suppose it is log of 1 minus x upon x and extending to 0. Then this thing can be rewritten in proper way. Log of 1 plus minus x I can write upon minus x, and I can multiply by minus 1. These are adjustments. See, whenever I want to use the formula log of 1 plus x upon x, limit extending to 0 is 1. For the problem log of 1 minus x upon x, so I have to bring that situation, then only I can use that formula. So that 1 minus x you can write as 1 plus minus x, and then denominator should be minus x, but actually denominator is x. So we have written for our convenience that minus x. So we should remove that effect of minus sign by multiplying again numerator by minus 1. And so now I can directly say that log of 1 minus x upon minus x, limit extending to 0 is 1, and that minus 1 is there in the numerator that you have multiplied. So the answer will be minus 1. So we can use this as a ready-made formula. Log of 1 plus x upon x, limit extending to 0 is 1. Similarly, log of 1 minus x upon x, limit extending to 0 is minus 1. Okay, and we are going to deal with problems like this. So definitely there will be some log involved in that. Exponential functions, e raised to x, a raised to x involved in that. So you have to also remember what are the logarithm formulae. Okay, you should know, you should recollect that already you have done it in logarithm chapter. But if a raised to x is m, then how it is written in log form? Log m to the base a is x. So exchange from exponential to log, log to exponential, you should be well conversant. Then log of 1 to any base is 0. log a to the base a is 1, so log 10 to the base 10, log e to the base e, log of any number a to the base a is always 1. Then also we should know that a raised to log of x is x. A raised to log of x is nothing but x. Then log of mn to the base a is log m to the base a plus log of n to the base a. Log of m upon n to the base a is log of m to the base a minus log of n to the base a. And log of m raised to n to the base a is n into log of m to the base a. It means power you can bring to multiple. If it is log of a raised to 5, I can write 5 log a. Okay, if it is 3 log a, you can convert that 3 which is multiple, you can take it as a power of a. So log of a cube, it will be 3 log a is same as log of a cube. But sometimes we make errors. Suppose it is log of a bracket square, then this is not equal to log of a square. This is different. Log of a square means what? A square is the quantity and its log is taken. But log a bracket square means what? It is log a into log a. These are two different things. This is where generally students make error. Sine square x and sine of x square, these are two different things. Sine of x square means x square is the quantity and its sine is taken. And when you talk about sine x bracket square, it is different. It is sine x into sine x. So brackets, in all the mathematical things that you write, brackets play important role. Brackets change the meaning. Remember, brackets, when you don't write or when you write brackets, it changes the meaning. So we have to properly use these brackets in your calculations. Then you also know that there is a change of base formula. Sometimes it is needed. See, because any formula that you are using about limits, log is considered with the base e. So log x, whenever you are writing, it is base e that we are expecting. So if the problem is given in terms other than base e, then first task is to change that to the base e. So you must remember change of base formula. What is that? Log of m to the base a is there, log m to the base a, and suppose I want to make this base b, then how you will write? It will be log of m to the base b divided by log of e to the base e. Log of m to the base b upon log of a to the base b. So this is the change of base formula, you know. Okay, so if it is log of say x to the base a, I can write it as 1 upon log of a to the base x. These are properties you have studied in chapter logarithm. So they are not new to you, but they will be very useful now in solving these problems. Also, in case of trigonometric limits, you should remember that sine x upon x, etc., whatever formula you are using, it is expected that x is in radians. So if it is in degrees, you must first convert it into radians and then use those formulae. Right? So whenever you are using mathematical formulae, not only for limits but anywhere, you must have a very proper knowledge of those formulae. When I can use that formula? Whenever your problem you are converting in a situation where you are eligible to use that formula, then only that formula can be properly used. So knowledge of formulae is very much necessary. Without that, you will not be able to solve problems. In case of degree and radian measures, in case of logarithm, change of base and all that, what is natural logarithm, what is common logarithm, all such things you must be aware of, and it will help you to solve the problems. So this is the beginning of exponential limits. More about that we will explore in further audios. I hope you enjoyed this audio. Thank you.